Hello and welcome to STW's training video number 2 on CoDeSys version 3. The particular version of CoDeSys I'm using in this video is version 3.5 patch 5. My name is Joe Stevenson, and the first video we went over was about creating a project and configuring all the options before we get started actually working with the project. And now here we're going to start by creating a function block and making some logic to read some inputs and set an output, a PWM output. And then we're going to make sure the project compiles, and we're going to create the hex file and then flash it to our controller. So what we're going to start with here is we're going to make a space between this here is all the initialization in PLC PRG, and then this is just the shutdown routine for the program in PLC PRG. So in between there, I'm going to make a little section and say application logic goes here. So what I'll do is I'll make a function block and I can put it here to do some logic. So I'll come to my POUs part of the project tree, right click and do add object. And here I can add a data type such as a structure. I can make a global variable list. I can also add another library manager. POUs, which is function blocks, functions, and programs are all types of POUs. And then we can add a visualization here. So I'm going to add a POU and I'm going to make it a function block. So function block is selected by default here, and I'll call it FB_handle IO, and I'm going to choose the language of structured text. Now all these other languages here are graphical type environments for programming, but I'm going to use structured text for this example. So now we're inside our handle IO block, and the logic that I want to do is I want to take two inputs, and if both inputs are true or 1 or on or however you want to say it, then we're going to set an output value of 5,000. And I'm going to use that because I'm going to be writing to a PWM output. And our PWM will have a range of 0 to 10,000. So 5,000 would be 50% PWM. Now I don't want to hard code IO values in here. I'm going to make it a generic function block. And then when I call this function block, I'll give it the IO variables to use so that this function block can be reused for anything. Sort of a general good way of coding to make things as modular as you can and not tied to any piece of hardware. So what I'll do is I'll start with an input variable and I'll say Q input. It's going to be a Boolean type. Now let's say Q input 1, so it'll be 01, and then I can copy and paste this down and make a Q input 02 for the second input. And we're going to have an output variable, and that'll be, let's say, an S16 output. And this will be the output, which will end up going to our PWM, and this will be of type int. Actually, I'll make this a U16 unsigned. And that will change this to uint. So these are just generic variables that are internal only to this function block. They're not tied to any hardware or inputs or outputs or anything. So I can make the logic based on these variables and then tie the actual input and output variables to them later. And how we're going to do that is I'll just make an if statement to handle the logic. So I say if Q input 1, and here I can use the autocomplete by pressing Control space, and it'll bring up what it thinks I'm trying to do, which this was correct, input 1. So I say if Q input 1 equals, and this is for comparing, equals 1, and here I could do 1, or I could do true, or I could do X on, which is hard-coded or it's defined as a value of 1. X off is 0, so I can do X on. But there's a difference here when I do this, because this is a Boolean. Q input is a Boolean, and X on is defined as a uint, I believe, or maybe a byte. So there would be a conflict there as far as the data conversion would go. And a little trick to turn this X on into a Boolean is to use the dot operator, and that allows you to access bits in the byte. So .0 would access the 0 bit, which would be 1 or 0, which will turn it into a Boolean. It's a little trick, it's good to know. So I could access, the 3rd bit here if I wanted, or 4th bit. But to keep it simple, I'm just going to do 1. And then I'll do and Q input 2 equals 1. So if both of the inputs are 1, they're on, then U16 output, I'm going to use the autocomplete colon equals, because we're actually writing a value to a variable now. This will be 5,000. What I'm going to do is I'm going to put an else statement here, just in case that's not true. Let's see, let me do that. Get back here. Else U16 output equals 0. So this logic will read the two inputs. If they're both true, it's going to set the output to 5,000. If this condition isn't true, if one or both of the outputs are not on, it'll set the output to 0. So now what I want to do is I want to call this from PLC-PRG to get this actually in my program. So I can use our input assistant. You can hit F2 or you can right click and do input assistant. Actually, before I do that, I need to declare an instance of that function block so that I can use it down in the code. So let's do that real quick. I'll call it FBIO, and it'll be of type FB handle IO. So now this is a local variable, which is an instance of this function block I created. So I can put that down here by right-clicking, input assistant, and now an instance calls FBIO is listed there, and I can hit OK, and it brings in the inputs and outputs that I have set up for that function block. So now since I want to use inputs, I'm going to go to my mainboard inputs and get the two variables that I'm going to use for my input. So this is the first input in the controller, input channel 1, this is input channel 2, and these are the two variable names that are tied to those inputs. So I can copy this, and I want to make sure these are digital types. So I'm going to come into the configuration tab, and I'm going to go to input configuration 1 and input configuration 2. I want to make sure they're both digital. So this is true. Here we go, digital and digital, so that's right. I'm going to come back to PLC-PRG. Now that I know my inputs are set up correctly, I'm going to put that handle on there. This is the handle for the actual input 1. And now I'm going to put the handle here for input 2. Let's change that to a 2. So now this function block is actually reading the values coming from the hardware inputs. And now the output I want to make sure is a PWM. So let me go to my mapping. So I'm going to use output 1 variable. So I'll copy that. And our configuration, let's see, I want to make sure it's a PWM type. Because I'll type PWM for 1. That's right. So I'm going to paste this here. And this is going to write whatever the value of output is to output 01. And notice the different syntax here between writing an output and writing an input. So if I hit F11 to build, we'll compile the project here, build F11. And we'll see that if there are any errors, we can see what they are. So the first error here, cannot convert D into bool. Okay, this is a Boolean input for our function block. Remember we listed that as a Boolean up here. But this handle for the hardware input 1 is not a Boolean type, it's a dint type. So I need to use the built-in function dint underscore to underscore bool. And I use the parentheses because it's a function call. So I'm using this as an input to this function to convert it from a dint to a bool. I need to do the same thing over here so that my function block can read it properly. And it's okay because It's just using the first byte or the first bit of the data anyway for the Boolean value. So now we have this properly set up at F11. And there's one more error, and let's see where it's going to take us. So then expected instead of, oh, I forgot the then here. So it should be then. So if condition then logic. So let's hit F11 one more time. And successfully compiled there. So now we're good to go. I'm just saving. And I'm going to create the hex file so that we can actually flash this program to our controller. So I'm going to go to Online, Create Boot Application, and Hex File. And what it's going to do is it's going to create two hex files, one with the runtime system for CoDeSys and one without the runtime system for CoDeSys. On the very first time you flash this program to your controller, you're going to want to use the hex file with the runtime system so that you can get that into the flash memory. After that, you don't need to because the runtime system is already there, and you can just flash the application only onto the controller. So here's the one with the runtime system. Here's the one without the runtime system. So since I already have the runtime system on this controller, I'm going to do the one without runtime system. So what I do is I come to WinFlash, and there's a training video that we've made, also available, that will show you how to use WinFlash. That would be very handy to use if you're not familiar with the program. So I'm going to turn the controller off, and I'm going to click Search Nodes and turn the controller back on to catch the bootloader mode. Found the device, I'm going to click Flash. So now I'm flashing it. It's erasing the sectors where the program is stored and rewriting the new program to it. And the program is flashed. I'm going to reset my controller. Hear a little beep, that means the program ran, because we got the little beeper on and off here, and then the LED is changing color on the controller, which means it's running. And the program will successfully flash to the controller. So now in the next video, we're going to go over how to log in and configure your PC for login so that you can see live data on the controller and we can actually see if this function block is doing what we think it's doing. Thanks for watching, and please move on to the next video.